Hey class, this is Gigi from Kauai Community College. This is a video on an application of those basic derivative rules. Okay, so first we are having a table of values here. So we don't really have a function. Whatever the functions are, we know these are the values that are given. So there's f of x, and then there's values for the derivative of f, and then there are values for the derivative of g, given at the points x equal to 1, 2, 3, and 4. So we are supposed to use this table to answer the question. And so first, the question here is asking you to find the derivative of f multiplied by g, and then this said evaluated at x equal to 2. So basic derivatives rules said that the derivative of the product f of x times g of x, so this is the product rule here, and this is just a straightforward application of the product rule. It said the derivative of the first function multiplied by the second function as is, plus the derivative of the second function multiplied by the first one as is. Okay, now since we are evaluating that at x equal to 2, wherever you see x, then you would put in 2. So that is what that means. That little line, x equal to 2, means now go and evaluate that at x equal 2. So now we look across to our table and we say f of the derivative of f evaluated at 2, meaning when x is 2, the derivative is 3. So that number right there is 3. Multiplied by when x is 2, g of x is negative 2. So that is what that is. And then plus when x is 2, the derivative of g is 4. And then when x is 2, the function evaluated at 2 is negative 2. So really here you have 6 plus a negative 8, which is a negative 2, and that is your answer. Okay, so what we should learn from this is that little line evaluated at means to go ahead and apply the rule, and then wherever you see x, you evaluate it at 2, and then you look over to the table to solve the problem. Okay, so the next one is also a straightforward application of the quotient rule. So the quotient rule said the derivative of a quotient, the function f of x divided by g of x. The quotient rule said, and we should know, all over g of x squared. That's what goes on the denominator. I always write that one first, so I remember. And then the first, the top part would be the derivative of the top multiplied by the bottom minus the derivative of the bottom multiplied by the top. Kind of like the product rule, except for it's going to be minus, and then it has all over g of x squared. That's what I remember. Okay, now again, we are going to go and evaluate that at x equals 3. So wherever I see x, I will put in 3. I love my pen, how I could go and erase just like that. 3. Okay, now just look across. to the table and find out what the values are. So the derivative of f at x equal to 3, so we're looking right here at x equal to 3. The derivative of f is 1. G of 3 is 4 minus the derivative of g at x equal to 3 is 1 multiplied by the function value at x equal to 3 is 3 divided by that g of 3, which is 4 squared. Okay, so now you just go and do your math here. Simplify that, so that would be the fraction 4 minus 3 all over 4 squared is 16, and that is 1 over 16, and that is your final answer. Okay, so for the next part of the problem, we're still using the same table. We are here applying the product rule, and here the product rule is being composed, the product is being composed of the function x squared and also g of x, which is given on our table. And then the x to the 5th power is just a function that we know the derivative of. So the derivative of the product x to the 5th multiplied by g of x is, applying the product rule, will be the derivative of x to the 5th, which is 5x to the 4th, multiplied by g of x as is, plus the derivative of g of x multiplied by x to the 5th as is, right? So derivative of the first times the second plus the derivative of the second times the first. And now we are going to evaluate that at x equals 1. So at x is equal to 1, then we will have 5 times 1 to the 4th power. And then g of 1, in this case, g of 1, we're looking here, g of 1 is 3. G of 1 is 3. Plus the derivative of g evaluated at 1, that would be negative 4 multiplied by x to the 5th, and that would be 1 to the 5th power. And then now we just go and finish our calculation. So we will have 5 times 1 times 3 is 15 plus negative 4 times 1 is a negative 4. So the answer here should be 11. Okay, so the third part of the problem is again applying the product rule with the function x to the 5th power and the function g of x being the second function. Okay, next we are still looking at the table, the same table of value. However, we are applying the quotient rule. And this quotient rule is with the first function being f of x and the second function being 2x plus 3, which we do know the derivative of. Okay, so if we were to write out our work, we would say the quotient rule says the derivative of f of x divided by 2x plus 3 is going to be the derivative of the top, which is f, the derivative of f of x, multiplied by the bottom, 2x plus 3 minus the derivative of the bottom, which would be the derivative of 2x is 2, the derivative of 3 is 0, so you just have 2 multiplied by the top as is, and then divided by the bottom square, 2x plus 3 square. Okay, so you see how I kind of memorize that quotient rule without saying the f prime of, so you just have to like look at the structure, and the structure is the derivative of the top times the bottom as is minus the derivative of the bottom times the top as is, all divided by the bottom square. That's what the quotient rule said. Okay, now we are going to evaluate that at x is equal to 4. So we're looking at this column there at x equal to 4. So when x is equal to 4, at x equals 4, we have the derivative of f of x, which would be, the derivative is right here, -1 multiplied by 2x plus 3. When x is 4, you have 4 times 2 is 8 plus 3 is 11 minus 2 multiplied by f of 4. And f of 4 is 4 times 4, all divided by 11 square. Now we just go ahead and cleaned out our answer. So you will have -1 times 11 is -11 minus 2 times 4 is 8, all divided by 11 square. 11 square is 121. So the answer should be -19 over 121. And that is our final answer. So conceptually, what we are doing here is applying the quotient and the product rule with a table of function values. So we don't have to actually deal with finding the derivatives and then having to evaluate. The values are given to us. Okay?